I will go ahead and get started. I'm sure some people are still wandering back in from lunch, but I did the thing that I always tell people not to do and put way too many slides. We have 55 slides. A lot of them don't have that much information, but yeah, I'll go ahead and get started. So my name's Tyler. I run the nonprofit organization Code Day. We've been around since 2009. We've helped at this point about 80,000 students use technology and creativity to make meaningful changes to the world. That's kind of always been our mission. I have a sort of unconventional background. I dropped out of college to run a VC-backed tech startup, but have sort of found my way into the nonprofit space. I don't have a PhD, but we've worked on a bunch of research and collaborated with a bunch of folks on research and things like that too. A lot of the work I'm going to talk about today, on that note, is funded by the National Science Foundation. The standard NSF disclaimer is they're my views, not the views of the National Science Foundation. I also wanted to make a quick pitch because I was asked to by the program officers. There's a really neat program in the National Science Foundation called Excellent. It's experiential learning in emerging technologies. They have grants of up to $1 million for up to 3 years. And I think a lot of people still don't know about it. So if you are vaguely research adjacent and have some cool stuff you want to do in experiential learning and emerging technologies, it's a really cool program. So definitely take a look at that. Okay, so what am I going to talk about today? So I'm going to go through four major things, and then we'll talk about the results at the end and how you can get involved. But the main things we're going to talk about are what problem we set out to solve. I want to talk a little bit about the disconnect that we found between the education community and the workforce. I'm going to talk a little bit about the format that we came up with, which is this idea of like an open source internship. How, if you are involved in the open source community, how can you help us get more students in open source? And then, as I said at the end, I'll talk a little bit about the results and some takeaways. And you're welcome to stop me if you do have a question, but I should have some time at the end for questions. So here's the problem we actually started out with. We were talking to a bunch of colleges in Washington State originally that have community college baccalaureate degrees. And the acronym is CCB. It's a community college baccalaureate degree. So you're getting a bachelor's of science or a bachelor's of applied science, a 4-year degree from a community college. That is a very great accessible path to economic mobility. It helps us create a stronger tech workforce. There's over 120 of these as of a couple years ago. I think that was in 2021, and it's probably a lot more now, but there's over 120 CCB programs that are relevant to the technology industry. Community colleges are amazing. They're super affordable. The average annual tuition is under $5,000. A lot of our students pay nothing because they receive government subsidies. Most of the students in these programs are lower income. They're in service industry jobs that have decided to go back to school to change careers. So it's awesome. It's a great program. It's a great opportunity for them. They're super smart students. They're every bit as capable as the students you meet from most 4-year institutions as well. But there's also still some problems. And one of the big problems is a lot of the students coming out of these degrees weren't getting jobs. So just to talk a little bit about what that looks like, underemployment is a big problem. A lot of students will graduate from these degrees and they will get jobs, but they won't get college level jobs. And the earning difference in these jobs is if you're a new grad that is in a college level job, on average, you're earning 88% more than someone who didn't have a college degree. But if you're underemployed, you're only earning 25% more than someone who didn't have a college degree. If you're in a job that doesn't require a college degree, you're not really getting much of a pay bump from having that college degree. So the students are missing out on a lot of economic opportunities by being underemployed. If you're interested in this more, there's a great report by the Strata Education Foundation and Burning Glass Institute called Talent Disrupted. It's got a lot of very interesting and eye-opening numbers. One of the other things about this is that they found in this report is underemployment is really sticky. So if students graduate and they don't get a college level job after graduation, they're likely to stay that way for a long time. You can see very few students are moving from this bottom line, which represents underemployed, to this top line, which represents having a college level job. Very few students are moving 1 year post completion, and even fewer students are moving 5 years post completion. If you get a college degree, but you don't get a college level job out of school, you're likely to stay that way. And what we found, as I alluded to, is a lot of our students are not getting college level jobs. So the New York Times a couple of years ago actually ran a full front page story on the CUNY college system in New York, which is one of our partners. We have some schools there that we work with. And they found that 50% of people with a technology degree graduating from the CUNY system in New York did not have a job in field 1 year after graduation. And this was in 2022. And you can imagine that that's probably worse now with the way that the tech industry has been going since then. One of the big reasons for that is only 10% of them reported having an internship during college. And I'll get back to that in a second. But that we think, and their professors have told us, seems to be a big factor in why they're not able to get employment in their field after graduation. So we saw these numbers. We saw that our students were having a lot of problems, and we were talking to the professors about, what can we do to help this. And what we decided to do to start off with is just talk to the employers and try to find out what is the problem. Why are these students not getting jobs? And some of it is a lot of people just don't even know that these universities exist. So that's an issue. But also a lot of it is just there are problems with the talent that schools are producing. So we did a study with hiring managers, and we started out by just talking to some people and asking them, what are the skills that someone needs to be successful in a tech job? And we did those initial studies, and then from there we put together a survey that we sent out to about 280 hiring managers, people who hire new grads. And we asked them for each of these things that we identified from those conversations, those skills that are important, how important are they to succeeding in this job? And what is the ability level that you are seeing from students? This is just sort of like a Likert scale, right? Like how relative to each other, how important are they? How much ability are you seeing from students? And then you can kind of figure out the impact by saying, well, how important are they multiplied by basically how bad are the students? And there were tons of options on this. It was lots of things like databases or APIs or Docker, like a lot of very specific options. But when we actually did this survey of 280 something hiring managers, what we found was that the most important things, the highest impact things, were all things about the ability to work independently. A lot of students today are graduating with CS degrees that don't know how to work independently. So the number 1, 2, and 3 most important things were managing change and uncertainty, identifying and defining problems, and experimentation, which are not really specific things at all, and they're things that are really difficult to teach in schools. If you want to read more about this, there's a paper about it. AI is probably making this worse because it's now easier to have an AI regurgitate open source code that it stole from the open source community. But it's much easier to get an AI to do a lot of stuff for you. And so it's harder and harder for our students to get jobs. We actually have some data that shows that since 2021, our students now need to apply for twice as many jobs just to get one interview. So it's harder for them to get the jobs. It's more important for them to be able to do something that AI can't do in the entry-level jobs. We did find that internships made a big difference. But they're really hard to get. There's been a bunch of work on this. These slides will be online, so if you're curious, you can look at the citations later. But Aman Kapoor has done a bunch of papers on this where he's looked at how many students are getting internships and why aren't they? And there's just a lot of challenges for students to get traditional internships. For our students, especially who come from these lower income backgrounds, a lot of them are primary caretakers for their family. They have a job that is paying their way through college and they can't quit that job because the job's not going to be there for them after this 3-month internship. That's a big problem. A lot of students just don't feel like they can do it. That's a big problem. And also they just don't have the time to prepare to get an internship. So we talked to students a lot. We had a lot of conversations with students, and we tried to figure out what are they looking for. So the first thing that they were that they were learning in these internships that they weren't learning right now is the expert fallacy. So this is just a mindset shift. A lot of students, one of the things that they were learning when they did an internship that they didn't have before, that they felt was helpful to them, was this idea of they had this conception that people in industry just knew the answer to everything. And dispelling that conception was one of the big things that they learned in internships. And it kind of makes sense when you think of what you do as a student. You spend like 15 to 20 years of your life in the school environment. And what do you do in school? You study for a test, and you study for a test, and you study for a test, and you study for a test. You're always studying for the next test. And if you get to the test and you don't know what to do, that is a bad thing, right? If you have a question on a test and you don't know what to do, that means that you didn't study enough, that you didn't know the correct answer to this problem is a problem for you. And of course, how do real developers work? This was a screenshot from a while ago. I think now there's probably more ChatGPT, but still, if you can see at the top of the screen there's a lot of Google searches and Stack Overflow tabs. So what we really need to do, what we found that students were struggling with, was sort of breaking out of this cycle of studying for a test and realizing that it's okay not to know what to do, and that when you think, I don't know what to do, shifting their mindset to, I don't know what to do, but I can learn. So that was one of the things that we found from all of these interviews with students. The second thing that we found that students were learning in these traditional internships that they weren't able to learn if they didn't get one was just the process that software engineers go through when we're trying to develop software. So this is something else. We did a bunch of interviews with our mentors who are professional software engineers and just try to understand what is the process that they go through when they're trying to solve a problem. And here is the process that we found. I think a lot of people here will find this very relatable. Most software engineers start out by just trying to figure out more specifically, what is the problem? What is going wrong? Where is it going wrong? In what way is it going wrong? So doing a lot of testing around the problem and trying to speculate or find ways to verify where in the code base the problem is happening. Or the feature that you want to add, where would that be happening? Do some research online. Figure out what your Google search terms are and plug them into Google search. Try to find out if there's an existing solution to this. Try a bunch of things, modify the code, see what happens. Like most of this code, if you run it, hopefully there's a testing environment or a local testing environment. Most of the time there is. And, because of that, you're not going to break anything. Figure out what works. Figure out whether this seems to work. Once you have one that you think is the best solution, verify with a bunch of testing to make sure it actually solves the problem for all of the use cases. And then this is the one a lot of people didn't do but would like to do, is document the solution. So that is the process that most of our mentors said that they're going through. But one of the things that a lot of the students were talking about was when they had an internship, they would realize, sort of by immersion, they would learn how to do this development process. And then the last thing is navigating real code bases. There's a lot of context that professional software engineers have built up about how software works. And when you think of that software development process, the first step is identifying and defining the problem. This is a picture of the Linux kernel. They got this from Wikipedia, and this is the simplified version. And for those of us who've done stuff with operating systems, you can, it looks very complicated, but you can kind of look at this and you can kind of figure out what's going on. and you have some idea of what's going on. So if I'm trying to debug a problem where I'm not able to do something with my hard drive, right? There's some problem with my hard drive. Well, first of all, I know it's in the storage column. And then what might I do as a software engineering professional? Well, I would probably try to figure out, is it a software problem? Is it a driver problem? Is it a hardware problem, right? That's sort of taking that column and splitting it up into different segments. And there are tests that I could do to figure out where in that column it's happening. And then, I can kind of work my way down into figuring out exactly where the problem is happening. And then I have a good place to start it. Real code bases are super complex. And this is very representative of a lot of the code bases that students would be working on. It's very representative of a lot of the open source projects. But we collectively, most of us here, have this context that we've built up over years of doing this that helps us figure out what's going on here and where to look. And a lot of students don't have that. And in the internships they were doing, they were starting to build up some of this context about how real code bases are structured. So again, where are we right now? Well, we figured out what is the problem that we're trying to face. It's that a lot of students are not getting these traditional internships, and so they're not getting jobs, right? They're ending up underemployed. It's not really living up to the promise of what they're trying to get out of their degrees. We figured out some reasons we think why. So now what we move into is the model that we came up with. So we had this idea of creating an open source internship. This actually came up in a sort of an interesting way. Code Day's been around, as I said, since 2009. I used to run a venture-backed tech startup. Like, I'm very much a technical person, and I had been contributing to open source since I was in middle school. All of the stuff that Code Day produces is open source. You can go on our GitHub and find all of our software that we write. You can find all of the documentation for how we do everything. It's all open source. So we love open source, and we've always been talking to our students about open source. We do a lot of stuff with high school and middle school students as well, not in the open source community, but just getting them interested in technology. And we 2018, I think, had this really amazing story where one of our students got involved in our open source, and then they got involved in making their own open source, and they built this cool project, which was the like a web UI for MakerBot 3D printers. And this is TJ Horner. You can see the name up there. They were in, I think they were in their freshman or sophomore year of high school when they started this project. And it took off. It took off on Reddit. And MakerBot saw this project and reached out to TJ and offered them a job building the software for MakerBot. And so TJ had this really funny, story of he has a job before graduating high school lined up already. And, the end of high school, they always make you do things in a lot of places where you have to put together a resume and show that you could be employable in the future. And, TJ is sending screenshots of their guidance counselors at their school, complaining because he has to do all this stuff. But he's like, well, I already have a 6-figure job lined up in New York. As soon as I graduate, I'm moving to New York and I'm starting my full-time job. So that was the power of open source. It's cool. It's fun. It's exciting. I love open source because of the agency it provides, and I love the creativity and the opportunities to make a difference in the world. But also, in a very real way, it does demonstrate a lot of technical competency for these students. So that was an amazing story. That was sort of where my brain started thinking maybe there's something we should be doing with open source, and it was sort of an inspiration a couple years later when we started working on this. The other thing that's amazing about open source is that it is really, really, really under-resourced. I think most of us have probably seen this XKCD comic. Yeah, there's not as many resources behind this. There's not as many people contributing to these projects as we would like. I think that's a shame. I think that there's so much cool stuff. I think a lot of the coolest software projects are open source, and a lot of them really, truly are maintained by one person, and some other people jump in and do some stuff every now and then when it solves their own personal problems, but there's not as much resources behind this as there should be. So knowing those two problems, we said, well, why don't we just take the students and connect them with an open source project? So that's kind of that's the basis of what we have put together in our program. Is we have 3 students and an open source project. I say 3, it's actually 2 to 4. We found out that just having one student doesn't work super well, because having someone to talk to was really effective. It helped them a lot in figuring out how to, having someone else to bounce ideas off of help students figure out the answer to questions and things. We partner with a bunch of open source projects, and each of the projects will give us a bunch of like good first issue style issues. We will, depending on the length of it and the complexity of it, over the summer, we actually let students pick what issue they want to work on. Over the school year, they're smaller issues, so we just assign them at random. But 2 to 4 students, one issue. We also match them with an industry mentor, and I'll talk a little bit about the role of the industry mentor in a second, but it's important to note they're not related to the open source project at all. We have some TAs. These are people that we pay that will sit down with the students and pair program with them, because the industry mentors, their time is very valuable. I don't have the money to pay industry salaries. So, they're doing this out of the goodness of their heart, but sometimes the students need a little bit more help. So the industry mentors are more of the high level guidance. The TAs are more experienced college students that'll sit down with them for hours on end and pair program. And then lastly, the open source community has, they have chats, they have forums, they have documentation, and they have mentors a lot of the time. And so they're providing this as well. So this is kind of the general model. This is the like architecture diagram of the program that we built. This is kind of generally what the structure of this looks like. So it's weekdays, 10 to 30 hours a week that the students are putting in on this. They can pick. A lot of our students work jobs. They can't do the 30 hours, so they'll do 10 hours, and we'll give them a smaller project. We start off by doing just general introduction to the technology and the framework. They're not really working on the project yet. They're just doing some tutorials to get familiar with it. We actually time box this to the first week, because otherwise students get into that the mindset of I'm learning. So they'll just spend the entire time like learning about stuff. So we time box it. You spend the first week learning, and then from there you have to go and figure it out. Week 2, they start building stuff. They look for what we have called starting points, places in the code base that might be related to the issue that you're trying to solve. That's the first step of that software engineering process. So, week 1 is like, what framework is this using? It's like React. Okay, I'm going to do some React tutorials. Week 2 is like, okay, I'm downloading the project. I'm cloning it. I'm getting it running in development. And I'm going to start messing with the code and figure out where this issue that we've been assigned is in this open source project. They also start meeting with their mentors, and on the next slide, I'll explain how that works. Then basically for the rest of the time, which could be in a total of 4 weeks up to a total of 12 weeks, the students just work on trying to make progress on whatever they're assigned to do. And then at the very end, they finish, they do their pull request. Sometimes they finish early, and then they do a second issue, which is great, but most of the students do finish. At this point, we're up to like 90% of the students who are opening a pull request. And then there's also a reflection piece. One of the things we found is that the students feel really bad at the end of this program, because they spent like 4 weeks and they changed 4 lines of code, and they felt like that was a failure because they thought their job was to write lines of code. That was also a misconception back in the 90s, and that's why we have the book, The Mythical Man Month. You spend a lot of time sometimes figuring out what code to write. Sometimes you spend a lot of time trying to figure out what lines of code to delete. It's not about the lines of code, but the reflection ended up being really important because students didn't understand how to contextualize what they learned. The important thing when you're going back to this model, what this looks like, the important thing to remember is that no one on this team knows the answer to the problem. This is a real open source project. It's a real issue in that project. The maintainers could probably speculate as to how to solve it. We don't ask them to, but they probably could. But no one knows the answer. The industry mentor, one of the interesting things we found was the industry mentor, it's actually really helpful for them to not know the answer to the project, so that we don't want them to be a subject matter expert in that project. And the reason for that is we're trying to do those 3 goals, right? We're trying to teach students the software development process. We're trying to break out of this mindset that an expert knows the answer to everything. And we're trying to help them build up that context. And if there's someone on your team that can just tell you, here's where to go to start editing the code, that doesn't solve any of those goals. So the role of the industry mentor is 1 hour a week. They meet with the students, all virtual, all on their own schedule. And the students basically say to the mentor, here's what we figured out. Here's what we're struggling with. And the mentor then will say, I don't know either. I have no idea how this works. Here's how I would approach this problem. So they might say something like, yeah, those starting points look like reasonable. My guess is out of the 3 options that you came up with, it's probably here, and here's why I would think that. If the students are having a problem, the mentor is going to walk them through, here's how I would figure out where in the code base this is occurring. So those are the sort of things that the industry mentor is doing. They're modeling that software development process, and they're demonstrating through their own, literally they can't know the answer to this because they've never seen this project before. They're demonstrating that real software engineers don't know the answer to everything, and it helps break out of that mindset. We've been really lucky. We have over 800 mentors that are active now, which is really cool. What are the TAs? Same thing. They don't know the answer. They're actually, at this point, they're more familiar with most of the open source projects, but they're very good at asking leading questions rather than answering that. That's something we do a lot in the training with them, is to make sure that they never answer questions. They give ideas for research and leading questions. And then we do have the project-specific subject matter expert mentors. The way that we've worked those in right now is we ask the students, if you have a question that you really need answered about this project specifically, work with the TAs and or your industry mentor to write it up into a very specific question, rather than just, I need help. It's, I need help with this. Here's the issues that I'm facing. Here's the error message. Here's what I've tried. That sort of thing. So this is really nice for our open source partners because it prevents them from being super annoyed because again, there's not that many resources for open source. They're already doing a lot of work, and we don't want to create more work for them. So this entire model is sort of structured around how can we not bother the open source mentors any more than we need to. So we do work with, I removed these slides from this deck. I've done this versions of this talk from other ones. I removed the slides that sort of explain what open source was, but I guess that removed our examples of partner projects. But some examples of the projects we've worked with, we've had a lot of students contribute to all of the Eclipse projects. They're a really long-term partner. We have had students contribute to CPython. We've had students contribute to Matplotlib. We've had students contribute to the software that Disney, Pixar, and Netflix use to build their movies. It's called Open Timeline IO. It's by the Academy Software Foundation. Students, like if you've watched a Pixar movie that was rendered in the last couple of years, our students probably had something to do with it. Our smallest project has 1 user, but the 1 user is NASA. It's called F Prime. It is the software that runs on the robots that go up into space, and our students have contributed to that too. So that's really cool. It's amazing the sort of impact that these students are able to have with these open source contributions. So that's really cool too. Okay, so how can you help if you're a maintainer? I'm going to quickly share some thoughts on how open source projects can make their projects more accessible to students. If you are interested in developing your own mentorship program based on what we've done, I'll give you some resources at the end. And of course, we're always looking for partner open source projects. So if you are a maintainer, we'd love to partner with you and do the exact thing that we've been doing. But generally what we found, first of all, offering any sort of proactive help is really helpful, right? That's kind of the basis. That's why we've done this program. If you want people to contribute to your project and you don't want to partner with us, that's fine. But I would recommend create some sort of mentorship program. CNCF, Linux Foundation, NumPy, or sorry, not NumPy, NumFocus. Also, the SFC, Software Freedom Conservatory. Like all of them have developed their own mentorship programs, and they're all great too. But having those are really important. Having a really good contributing guide is another thing that we found that's really important for us and our partner projects. Talk about things like resources. Where can students go to ask for help? Do you have like regular calls? Is it just sort of Discord? What's available? What are the coding conventions? Things like that. Most of our projects have documentation for setting up a dev environment that has at least a couple bugs that just like things don't actually work if you follow the instructions. This has been such a big problem that at this point we will actually pay students a bonus up to $128 just if they fix documentation that prevents the dev environment from building. So that's one of the nice things we've been able to offer our partner projects is like you'll get a bunch of students testing this and they'll open pull requests to fix the documentation for you. But yeah, it's important. It's also a lot of our students are lower income. They don't have a Mac computer and they could install Linux, but many of them don't. So it'd be nice if it runs on Windows in virtual machine or something else. Having working linting tests in like a CI pipeline so that when the students do a pull request, they get feedback immediately is really helpful, because it kind of sucks if you open a pull request and then you wait 2 months for a maintainer to review it, and then it turns out that you accidentally use tabs instead of spaces, which is something, again, obvious to people who've been around for a while, not as obvious to students, and it just, it sort of, the students don't necessarily have time then or whatever else. It just slows things down a lot. This is getting into things that people don't tend to have, but would be really helpful. Having an architecture file that describes how the pieces fit together, that sort of Linux kernel diagram that I had earlier, we found that it's really helpful for students to have something to refer to understand how the data flows through the app. And lastly, having a bunch of good first issues is really helpful. Having things tagged that are, this is what we've found to make a good first issue. Something that's self-contained, so doesn't require a lot of tracing across the code base. It tends to be solved in one place. Enough detail in the issue that they don't have to ask for clarification and wait for someone to get back to them. Decided, so doesn't require a discussion. A lot of the issues that we've seen tagged in good first issues from some projects tend to actually require the students to make a design decision, which is not really something a first-time contributor is comfortable doing, and is going to take a long time. And then recent, a lot of good first issues are just older, and we used to assign the students to just any good first issue, and then we would find that it was actually solved and someone forgot to close it. So if you want to take a picture of it, this is the kind of the summary of all the slides. So okay, so I'll talk about how this worked, and then we can get to some questions. So we have had 1,557 open source contributions. This is as of 4 weeks ago, so it might be up a little bit higher now. 472,000 hours of students learning and working on these open source contributions. 20,000 hours of mentorship. So all of these things are really cool, and I'm really happy about them. We have a lot more data than that, but I didn't want to go through all of it. What do some of these projects look like? Here's an example. This was a mentor. I think it's actually wrong. I think he works for Snap now, but this is a mentor that helps some students add the ability to visualize self-driving car sensors to an open source data visualization project. So it takes the format that self-driving cars, or that a lot of self-driving car LiDAR sensors were producing, and it displays it on a map in this open source project, which is really cool. And obviously very helpful. This was one of our first projects, and actually Omar, the mentor for this, was an alumni of our high school program, and then an alumni volunteer, and then he was one of the first mentors, so he's great. And then here's another example. I don't know why I just picked 2 data visualization projects. They tend to look better than fixing a test. It's kind of hard to demonstrate that. This is a project called Hubble GL that visualizes 3D environments, and it's used a lot for visualizing like airspace and things like that. It's a time series data. So you would be viewing something over time. People used to just screen record this if they wanted to share something. So now they added the ability to export like an MP4 directly from the tool, which is pretty cool. And this was mentored also by one of our alumni, Chris Gervang, who literally, I think both of those were volunteers back in like 2012. So they've been around for a really long time. It's great. Chris now works at Joby Aviation. I think the people who make the tripods, literally the same founder started a flying car company. So he moved from Uber Elevate over there. But yeah, very cool. Self-flying cars, which is really cool. So those are some examples of projects, but again, we've had a lot of other really cool things. One thing that we did early on was we asked mentors to rate students just on sort of a Likert scale. How are they doing with understanding that software development process? This is not necessarily the most scientific way to do it, but the trends are still kind of interesting. So you can see, the left side is basically the higher up they are, the better the students are at going through that software development process. The y-axis, the x-axis is the week in the process. And what we saw was that the students started out not that great, a little bit over 50% in terms of the Likert scale rating. It actually went down. So the students were doing worse for the first couple weeks. But then what we saw was after about week 2, it seemed like things started to click for students that like, oh yeah, this isn't a mistake. It's not that I'm stupid, and it's not that the program is poorly designed. It's that actually truly like no one knows the answer to this and I just need to figure it out. And so what we saw was actually the students made a pretty big improvement in this in terms of their mentor evaluations. I'm sort of not describing this super great, but there's a paper you can read if you're interested. And we've been doing some follow-up work on that too. Another cool thing that came out of this is these blog posts. So we work with another organization called Mentors in Tech that does sort of more career mentorship stuff. In collaboration with those mentors, as I said, the students reflecting on this turned out to be really important. So we worked with them, and we have the students now publish these blog posts on LinkedIn. They talk a little bit about what they learned in the process. They talk about their learnings as a individual student. They also talk about what they learned about the project. So they'll create an architecture diagram based on their understanding of the project. They'll talk a lot about how the issue was solved and the code base and stuff like that. Really useful reflection for the students, but it's also really cool to read about these contributor journeys. You can search for these. I think if you search for Code Day Labs, you'll find tons of these on LinkedIn. There's definitely hundreds of them at this point, and they're all really fun to read. We do, at the end of every year, we do like a blog post recap of our favorite ones according to the mentors' votes. So you can keep an eye out for that too. Okay, so lastly, some ways to get involved. First of all, if you're an open source maintainer or you want to be a mentor, again, you don't need to know any specific open source project. You can come talk to me. We have a community of practice that we've put together called Floss Mentoring. It actually sort of came out of FOSSY last year. We got like 60 people. It was started by myself, some people from the UCSC OSPO, particularly Dr. Emily Lovell, who's not here, but I don't know if Steph is here, but there's a couple people here who are involved in this. If you're interested in mentorship, we have calls every month. So you can scan that QR code. I think that will take you to the GitHub, and there's links to sign up for the monthly calls. We also recently just hosted our first unconference at the Open Source Summit in Denver. Thanks to CNCF for giving us one of their rooms for half a day. So yeah, if you're interested in mentorship, this is a great opportunity. We have a Discord where we collaborate on trying to put together event proposals and things like that too. There's a bunch of papers that we've done on things like this. Actually, one of the ones that I linked to in here that's super interesting is by Steve, who's right there. And then we also have 3 that are pending at SIGSI with some collaborators at Cal State University Monterey Bay and with the Washington State Board for Community and Technical Colleges. So those aren't out yet. They're submitted, but I'm happy to send preprints if you want to talk to me. There's my contact information. I will figure out how to share these slides with people. I don't know if there's a place to do it on the website, but if not, it'll be on my website. And yeah, I'd love to take questions and just chat with whatever time we have left about mentorship or making projects accessible to new contributors. So thank you for coming.
Sound like it's being that's just being recorded. Okay, all right. I have a question about the good first issue.
Yeah.
I'm part of a project, Postgres, which tends to react to good first issues as saying, well, we would have fixed those already, which is kind of counterproductive when it comes to inviting new people in. I was wondering if you had any recommendations of projects that do this really well.
My favorite project for doing this really well is Open Energy Dashboard. It was, I don't know if it's founded by, but it's certainly very heavily involved. Dr. Steve Huss-Lederman. Uh, he's really involved in the humanitarian open source software movement, HFOSS. But they do very specifically make the decision that yes, it will take as much time to write up what is a good first issue as it would have taken to solve the good first issue a lot of times. But that's okay, because if we get a new contributor from that, in the long term, that's still paying off, right? So it's sort of like a deferred satisfaction thing. Like, yeah, like I could just spend my time solving the issue right now, and I'm going to feel really good about myself for solving this issue. But, if you get a new contributor, they're going to solve 4 more issues, and you don't have to spend any time doing that. So there are projects that do that well, but I completely agree with you. I think you have to make the decision that it's worth the time investment to attract new contributors. Otherwise, yeah, you can just solve them yourself a lot of time, especially I'm sure Postgres is a very complex code base.
Hi, great presentation. And I might have missed this. So I apologize if you have to repeat yourself.
No worries.
But how do you choose the open source projects? And is there any sort of like conversation with the project ahead of time that they're going to be like students working in the space? And how do you also, you said there are 2 to 4 like students together that work together on a project. How do you ensure that, especially with that trend line that you said, like that they continue for the entire extent of the mentorship series, rather than like get frustrated and walk away?
Yeah, great question. So as for how we choose the projects, there are a couple things. One of them is this list, right? We want all the projects that we work with, other than mentorship, because we're providing that, but we do want them to have like good documentation. I guess we don't require the architecture file either, but like they need to have a good contributing document. They need to have a dev environment that's pretty close to building. Ideally, we want CI, and they need to have things tagged as good first issues. So that's kind of a requirement for us. Other than that, we're looking for projects that people use, and we're looking for projects that the students care about. And myself and some other people on our team just go to a bunch of conferences and try to meet people like that. We do a survey with our students every time to try to figure out what their interests are. And then we'll go look for projects like that. So for example, we found out a lot of our students used to be using a lot of government programs, things like food stamps or government grants for things, because our students come from low income backgrounds. So I, a couple months ago, went to the Code for America Summit, which is where a lot of the people who build that software hang out, and try to get some projects related to that. We found out that, for example, the city of Seattle builds an open source software project that a lot of cities use to manage their grant programs to individuals for like eligibility and the forms and all of that stuff. So having the opportunity for students to contribute to that would be great. And that's a conversation that was started out of that. So that's kind of how we do it. It's a lot of just like going around and talking to people, basically. As for how do we keep the students engaged? So that is a very interesting question. The first year we did this, we allowed anyone to register. You could just go on the website and apply. And we had this criteria. We had a system we built for like rating applicants. We would get as many people in as we could. And what we found was that a lot of students were dropping out. The first year we had, I think, over 50% of the students were dropping out. And it probably was because of the frustration of it. A lot of students do complain to us that at the start of the program, they feel like there's something wrong because their mentor doesn't know the answer, and they're upset about that. So what we ended up doing was we partner with schools or other organizations that know the students really well, and work with them on an ongoing basis. And so when the students are feeling frustrated about that, or if they're not showing up to things, their school can go and talk to them and say, hey, like you missed a couple meetings. What's up with that? And that sort of takes them through that period. So that has been one of the most important things we found, is that the students who don't have an accountability mechanism built in often don't make it past that barrier. I think we'd like to do more for that. Team dynamics is an important thing that we're trying to figure out more about. We're also doing with another issue with teams, right, is like a lot of students don't work together very well. Like one student will do all the work or something like that. So that's, we're doing a lot of stuff there around the team dynamics to try to improve the number of students that stay in the program and are successful.
Oh, sorry. I have one more quick question here. So I'm with a group that's put in a ton of time and effort to all those documents that you're clicking away from.
Sorry.
But one thing that I've learned over the past little bit is that just because I've written it up and it's clear to me, that doesn't necessarily mean that it's clear to anyone else who's coming in.
Yep.
So what types of kind of checks and support do you have for partner groups that are coming in who maybe even want feedback on their documentation, because if this is the target group they want to be working with, these students, they need to make sure that that's clear.
Yeah, so that is a very common problem. I think that's a problem with almost everything that we produce as well. Like, we have a lot of context and it's hard to remember what to write out. For Code Day, we've made it a priority that we want to improve those documentation assets. So that's why, after week 1, when the students are starting to get into getting their project building, we will remind them, as you see an issue, open a pull request to fix the documentation, send us a link when it's merged, we'll pay you extra money for it. And that, for us, that's important. I don't know how projects can do that independently. Obviously, not a lot of people have the money to pay for that, and we don't really have the money to pay for that if it got too popular. But I think, to some extent, just emphasizing that you're looking for pull requests on documentation is helpful, and it is valuable. Another thing is, I think a lot of people also just undervalue the importance of documentation. A lot of students don't even think it's important to have documentation. And of course, when we talk to the employers, they love to see that sort of contribution, but the students at least don't think it's, is important. So I don't know, it's no easy answer, but I do always recommend, whenever you have a new person who's going through the documentation, as much as possible, ask them for feedback is really helpful.
So do you think that, say, an AI system would help with making mentorship easier for the students? Or
there are ways that it can make mentorship easier, and there are ways that it can make mentorship harder. Actually, I think Steve is working on some stuff with that right now.
We are working on a paper. There is no empirical findings right now. We invite our research team is from the industry people and academia. We are visioning the impact of the AI to the open source. Part of the aspect is about the mentorship. And there are some negative aspects. There are some positive aspects. Yeah. And if you are interested, I can give you the preprint. Yeah.
Yeah. So Steve's a great person to talk to about that. I'm glad he's here. But I think, on our side, there's a lot of ways that it can improve it. One of the things that we've done, for example, is we have students do asynchronous stand-ups. So every day on Slack, they'll post kind of, here's what I did, here's what I'm planning to do. And we actually have a LLM go and look at that and say, is this vague or specific? And then also, is it changing from day to day, or are they saying the same thing every week? And that actually, for example, that allows us to flag students that are struggling. Because if they're saying the same thing every week, or if they're saying something really vague, like I worked on the issue, and they do that a couple days in a row, I'm not saying that we need to penalize their grade or that they're failing or anything. It's an indication to us that they're struggling and they need a mentor or a TA or someone else to reach out to them and try to troubleshoot what's causing that problem. So we've had a lot of success with using AI in ways like that to identify issues. But yeah, there's a lot of other things you can do for AI. And again, Steve's a great person to talk to about that.
So we're officially 4 minutes.
Cool. Thank you.